Howdy, my name's Josh. I contribute to Kubernetes for Red Hat. It's my job. Nice job. I've been contributing to Kubernetes actually for about three and a half years before I worked for Red Hat. And when we started, Kubernetes container orchestration in general was strictly for stateless services. But since then, we've been adding a lot of technologies and a lot of approaches and practices to make it suitable for stateful services, things like CSI and Rook and even sophisticated agents like Vitess. And that means that you can now host your database or your CDN or your queuing system or whatever it is on Kubernetes and on a cloud-native stack. But should you? Now, part of should you is, what does performance look like? That is, what kind of penalties am I going to pay in terms of latency and throughput and response time when I move to this newer, bigger, more complicated stack? Now, I thought maybe we'd have an answer for that in the Kubernetes community, and we do have this team called SIG Scalability that looks at performance. But they look at the performance of Kubernetes components, things like pod deployment speed, etc., not the performance of applications on top of Kubernetes. Now, it just so happens that I have a long history of performance testing applications, namely databases going back about 15 years. I've run a lot of database benchmarks, and transactional databases are a really nice way to test the performance of a system because they work multiple parts of a system simultaneously. Not just compute, but also network and memory usage, and above all, storage. So I pulled together a bunch of highly available open source databases, MySQL Sysbench and PGBench, and CockroachDB released a nice TPCC benchmark, and decided that I would actually go ahead and try these out on a few different cloud native stack compositions. Put them on a little test cluster that we actually have within the office, the CTO at Red Hat. This is actually something you'd reasonably run a production internal cloud on. You'd want to have more than one network, but other than that. And I ran these. Now, I'm going to show you the results of this in a sort of gridded shorthand. And so these squares of the grid mark what the different results are, because you'll see that performance doesn't change uniformly across all measures when we change environments. We need a control, and this is going to be a bare metal test, where we run this without any Kubernetes running at all, and we run the benchmark workloads on bare metal on a couple of those blades, or on all of them in the case of CockroachDB. Now, our first Kubernetes setup we're going to do is something called local volumes, either persistent local volumes or host path, where the storage is co-located with the workload pod, with the pod running the database or whatever, on the system. And this should give us near bare metal performance, and indeed it does on the raw file system tests, that we see that the difference in performance is almost indistinguishable from running it on the bare metal. But for the more sophisticated database tests, you actually see a substantial 10 to 15% penalty. Well, if the storage performance is almost indistinguishable, where's that coming from? Well, remember I said we work out multiple aspects of the system at the same time. And one of the things that's happened is by putting this in Kubernetes, we put it on a much more complicated network. We have a network overlay, we have discovery services, and that adds latency to each new connection to the database workload, which is not substantial, but enough to show up in some of these database benchmarks and enough to show up on short transactions in reality. Now, next we're going to get more complicated. We're going to do cloud native storage, which is when you actually have a storage agent like Rook and a distributed file system like Ceph. You containerize that, you put that in your Kubernetes cluster itself, you network it together, and then it supplies storage for the cluster. Now, since this is a redundant, highly available file system, we expect to pay a performance penalty because you don't make multiple copies of something without paying for it. But how much? Is it a tolerable performance penalty? That's what we want to know. And the answer is, yeah, probably tolerable. Depends on how much you need that redundancy, right? So again, raw storage doesn't look that bad. As a matter of fact, for some things like writing multiple files in parallel, we actually get a boost in performance because we can distribute that workload over multiple machines. But for things like short synchronous transactions, we pay a penalty of about doubling the latency, which then cuts the throughput on some workloads in half. Now, whether or not that's worth it depends on how much you care about redundancy. But what we've seen overall is we can make the same kind of trade-offs of availability versus performance on Kubernetes that we could make on bare metal, and the performance is comparable. So give it a try, and we'll talk about it in open spaces.